Sliding down my son's luge run, I realize I am going too fast and will crash into a tree that is 200 feet in front of me if I don't put my foot down to brake. I am going 50 feet per second. If I decelerate at a constant rate of 7 feet per second, will I hit the tree? Show all equations. So we'll begin with our constant acceleration, decelerating at 7 feet per second. I think that means we should make a -7 to represent that we are slowing down. I'll put the t here to highlight the fact this is a function of t. Let's integrate both sides of this thing with respect to t. The integral of acceleration is velocity, so the left-hand side is v of t. Integral of -7 dt is -7t plus a constant. Let's find that constant right now. I'm going 50 feet per second. Let's go ahead and start the clock at what we call 0 for time. On the one hand, v of 0 is given as 50, positive 50. On the other hand, we can plug 0 here for t. The right-hand side is simply c, so that means that c is 50. So the velocity function is now -7t plus 50. And let's go ahead and integrate both sides of that with respect to time. Because the integrand is now more than one term, it needs parentheses. The integral on the left-hand side, integral of v of t, is just the position function. Let's call that s of t. On the right-hand side, -7t squared over 2 plus 50t plus a constant. Okay, how do we find this constant? I suppose you could use the 200 if you wanted to. You could call it -200. It really just depends on how you set up your axes. So I'll set up my axes. It's really just one axis, right? So I'll set up my axis here. So I'm going to say 0 is at the start, and then the tree is over here at 200. And so that means that I am defining s of 0, so that's the beginning of the experiment, to be on the axis at 0. But you can make a different choice, and that would give you a different c, and that's okay. So -7 times 0, 0 squared divided by 2, plus 50 times 0 plus c. Right-hand side is just c, so that means that c is 0 according to what I've defined my axes to be. So s of t is now -7 over 2t squared plus 50t, and then plus nothing. I won't write anymore. Okay, we want to know if we're going to hit this tree, so it feels like the 200 has to play a role soon. But I'm actually going to pause on the 200, and I'm going to ask myself, how long does it take to stop? I'm going to forget about the tree. I'm going to hope I don't hit the tree, but let's ignore the tree completely and just ask ourselves how long it takes to stop. And once we find out how long it takes to stop, we're going to take that time and plug it right here to figure out how far we go until we stop. And let's suppose that we go 190 feet before we stop. Well, that's great. That means we didn't hit the tree. But if it turns out we don't stop until we are 220 feet, well, that's a real problem, because that means we hit the tree and we were still moving. We would have gone another 20 feet before we hit the tree, or after we hit the tree, we would have continued another 20 feet. So that's the plan. Let's set the velocity equal to 0 to find when we stop. So that means that 0 is equal to -7t plus 50. Subtract 50, divide by -7, and we get t is 50 over 7. That's how many seconds it takes to stop, a little bit over 7 seconds. And then we plug that into the position function, s of 50 over 7, -7, 50 over 7 squared over 2, plus 50 times 50 over 7. And we're going to calculate this. We're going to cross our fingers and hope that it is something less than 200. Okay, here we go. So I'm going to take that 50 over 7 and I'm going to store it as x. Store x. So this way we don't have to type it a couple of times. So we go -7 x squared divided by 2 plus 50 x. It's basically just typing this thing in, but using x instead of t. Okay, more or less than 200. hey, less than 200. So that's around 178.6 feet. So we don't hit the tree. We stop about 21.5 feet before we get to the tree. I think there are other ways to solve this. You could, for example, not find the 50/7 here, but rather just say, okay, what if we set this equal to 200? And if you set it equal to 200, you're going to find time. You're going to find out how long it takes before you stop. And then you can take the time that you calculate and you can plug it in here to calculate to plug it into here. You can calculate your velocity by the time you hit the tree. And so if your velocity is still positive when you hit the tree, that's a problem. That means you smacked into the tree. But if your velocity is negative when you hit the tree, that means you actually stopped before you got there. That would involve solving a quadratic equation. Remember, we were making this equal 200. It's not hard, but I think solving the linear equation here is the simpler way to solve this problem.